Welcome to Cognira. Chapter 1. Identifying the data debt. By 2026, the cost of data debt is no longer just a line item in the IT budget, it is a systemic risk to the viability of the AI-native enterprise. Below, we decompose the 9 silent killers of data systems using the STAR framework to provide an audit-ready architectural path. The semantic gap. Problem: the distance between raw data columns and actual business meaning. Situation: in legacy architectures, revenue or customer churn is calculated in the SQL of a BI tool, the Python code of a data scientist, and the system prompt of an LLM. These definitions inevitably diverge, leading to a war of the dashboards where the CFO and CMO report different numbers for the same KPI. Task: guarantee a unified semantic plane where a single definition of a business entity is consumed by all downstream interfaces, SQL, API, AI. Action: decouple logic from the consumption layer. Implement a headless BI/semantic layer. Example: metric store, where definitions are stored as version-controlled code. Enforce that AI agents query the semantic layer via API rather than raw tables. Result: 100% consistency in cross-functional reporting. Reduction in AI logic hallucinations by ensuring models only consume pre-calculated, verified metrics. Data gravity and latency. Problem: data is too heavy to move or arrives too late to be actionable. Situation: T+1. Next day, data availability posture is standard in legacy batch processing environments. In 2026, this results in AI agents making decisions based on yesterday's reality, leading to stockouts, missed fraud signals, and frustrated customers. Task: shift the architecture to a right-time availability model where latency is a defined SLA based on the use case. Action: replace bulk ETL with change data capture to stream database changes in real time. Adopt a zonal architecture, operational, analytical, AI, that minimizes data movement by bringing compute to the data. Example: iceberg/hoodie tables on S3. Result: real-time operational intelligence, elimination of stale data, failures in automated supply chain and customer service agents. The black box compliance risk. Problem: lack of provenance and explainability for automated decisions. Situation: organizations deploy AI models that influence hiring, lending, or pricing without a clear paper trail. When an auditor asks why a specific decision was made, the organization cannot produce the exact snapshot of data used for that specific inference. Task: ensure full traceability and provenance to comply with the EU AI Act and industry-specific regulations. Action: implement open lineage across all pipelines to track data from source to model. Store inference snapshots, the exact features and model version used for every high-stakes AI decision. Result: audit-ready posture, 0% unexplainable decision risk, protected brand reputation. Schema drift and silent breakage. Problem: upstream changes break downstream systems without throwing an error. Situation: an engineer changes a user underscore ID from an integer to a string in a production database. The ingestion pipeline continues to run, but the downstream ML model fails to join the data, resulting in null features and degraded model performance that goes unnoticed for weeks. Task: enforce data contracts as a mandatory deployment gate. Action: implement a schema registry that blocks upstream changes if they violate the contract signed by downstream consumers. Use CD gates to run data impact analysis before any schema modification. Result: 0 silent breakages, 40% reduction in data engineering firefighting time. Orphan logic, business rules hidden everywhere. Problem: business logic is scattered across disconnected scripts, dashboards, and prompts. Situation: critical logic. Example: exclude internal test accounts from revenue is hard-coded in 50 different places. When the test account naming convention changes, only 20 of those places are updated, leading to systemic data corruption. Task: centralize and version control business logic as a platform asset. Action: migrate logic from dashboard SQL to upstream transformation, silver/gold layers. Use a centralized policy engine for business rules that are accessible via API. Result: single point of change for all business rules, simplified audits, guaranteed AI/human logic alignment. Data trust decay. Problem: cultural rejection of data systems due to perceived unreliability. Situation: after 3 high-profile dashboard failures, executive leadership reverts to gut feeling in Excel spreadsheets, ignoring the $50 million data platform. Task: restore and maintain data trust through observability. Action: publish a public data health dashboard, showing service-level objectives for every critical data product. Implement automated circuit breakers that stop data flow if quality checks fail, preventing bad data from reaching the CEO. Result: increased data-driven decision frequency, measurable ROI on platform investment. AI feedback loops, self-reinforcing errors. Problem: AI models consuming AI-generated data, leading to model collapse. Situation: an LLM generates marketing copy. A second LLM is trained on that copy. Over time, the second model becomes bland and repetitive because it lacks the entropy of human-generated data. Task: prevent model autophagy by distinguishing human versus synthetic data. Action: incorporate provenance metadata, human-generated versus AI-generated, into the core data schema. Use causal inference techniques to monitor if model outputs are poisoning the next training set. Result: long-term model performance stability, prevention of bias amplification loops. Ownership vacuum. Problem: if everyone owns it, no one owns it. Situation: a data quality issue is found in the customer table. The data platform team says it's a source problem. The source team says they just store what the app provides. The app team says it's an analytics problem. Task: transition to domain-oriented ownership, data mesh. Action: assign data product owners within the business units, e.g., marketing owns the customer data product. Define the platform team as internal SaaS providers who provide the tools, not the data. Result: 60% faster resolution of data quality issues, clear accountability for data value. Cost explosion without value. Problem: infrastructure spend grows exponentially while business value stays linear. Situation: in 2026, uncontrolled GPU and vector DB costs can bankrupt a project. Organizations ingest petabytes of data just in case, without understanding the cost-to-value ratio. Task: institutionalize data FinOps. Action: tag every data asset with its consumption cost. Implement automated lifecycle policies, e.g., move data to cold storage if not queried for 60 days. Require a value case for all new high-frequency streaming pipelines. Result: 30% reduction in cloud OpEx. Alignment of data spend with actual business growth. Thanks you for listening Chapter 1. We will meet again in Chapter 2.